Okay, guys, today's lesson is on light rays and reflection. A light ray is a line and arrow that represents the direction and straight line path of light. And if you'll recall from previous lessons, light travels in a straight line from the luminous source. So a light ray is what we use to depict light, but it's drawn with a straight line. And it also includes an arrowhead that represents the direction that it's actually pointed towards. When we say a beam of light, we mean many rays of light moving in the same direction. For example, you'll notice that I have a light source here in figure A, and you have one light ray radiating from it. You see it's a straight line with an arrowhead showing that the light is traveling to the right. In figure B, you're seeing beams of light rays, so more than one. They're all traveling in the same direction. And I can tell that because all the arrowheads are pointed in the same direction, okay? So a straight arrow represents one ray of light. A group of straight arrows pointing in the same direction represents a beam of light. Here we have a candle. That is our luminous light source. And so obviously candles emit light in all directions, and we can represent that visually with beams of light. So you don't have to draw a million beams of light, but you can draw enough to give the person looking at your image the understanding that there is more than one beam of light or light ray that is radiating from the actual luminous source. So again, you have a straight line with an arrowhead that shows direction. And you'll notice that every beam of light is traveling in the same direction. Okay, now we're going to talk about plane mirrors and how light hits and reflects off of a plane mirror. Now, it's important to know, and let me just get we're talking about plane mirrors here. Let's highlight this, okay? We're not just going to call them mirrors because there is a difference between a plane mirror and a curved mirror. So a plane mirror is a flat reflective surface. So think the majority of mirrors that you encounter in your everyday life are plane mirrors, but there's also curved mirrors that exist. And the behavior of light on a flat mirror and a curved mirror is different. So right now we're just going to be talking about a plain flat reflective surface when we talk about plane mirrors. So there's two parts to a plane mirror. There's a sheet of glass that acts as that transparent substance that allows the light to actually travel through it. And then behind it, there's a reflective silver or aluminum sheet that is opaque that allows the light rays to actually bounce off of it. This is what it looks like. So this is an actual plane mirror. So let's just make sure this is a plane mirror, okay? So you have, here's your glass. And your glass is important because it's transparent, right? So it's transparent, which means that the light rays can actually penetrate and travel through it. But you don't want the light rays to travel completely through it, or you're actually not going to see an image. So that's why this reflective thin film is important, because it's opaque. And what ends up happening is the light travels and then bounces off of it, right? In science, we're going to call the glass sheet part of it the reflective surface, and then we're going to call the back side of it the opaque side, okay? Okay, now let's talk about reflection. So reflection is the bouncing back of light off of a surface, and reflection is why we see things in the world. So our eyes receive reflected light that comes off of an object, and it penetrates through our eyes and travels through our optic nerves into our brains, and our brains can decide what image we are actually seeing it. So they take that information and they translate it into an image for us. So when we demonstrate this on paper in our optics unit, we have to be familiar with some terminology here. So you would have a light source here. So the light is coming from somewhere, okay? The light source emits light, and the light ray travels down until it hits your plane mirror. So remember, this is your mirror, okay? So your light source has light coming off of it. It travels, it hits the mirror, which has this reflective surface. Once it hits the mirror, it's because of that opaque background, it's not going to allow the light to penetrate straight through. It's going to be bounced off and reflected, and then here would be somebody's eye, and your brain would then perceive that image, and you would be able to see something. Okay, so the light ray that comes in is called the incident ray. So you need to be very familiar with this terminology. So the light ray coming in is called the incident ray. The arrowhead for the incident ray is always pointed towards the mirror because that light ray is coming towards the mirror. You'll notice that there is this dotted imaginary line. So this is not real. Okay, what we do is in science we use it so that we can actually measure the angle that the light ray is coming in as opposed to the angle that the light ray is bouncing off at. So the normal is always a perpendicular line. Okay, so it's perpendicular to the mirror. So you're always going to have to draw it. And you draw it as a dotted line to show that it doesn't actually exist. Okay, and it's always drawn at a 90-degree angle to the mirror right here. Okay, so the incident ray comes in, it hits the mirror. The angle of incidence is the angle that the incident ray makes between the normal and the incident ray. Then once that incident ray hits the mirror, it's bounced off, it's reflected. So that reflected ray is obviously called a reflected ray. And then the angle that it bounces off at is called the angle of reflection. The angle of reflection is measured from the normal to the reflected ray. So this is always from normal to reflected ray. Some people get confused and don't measure it from the normal. It has to be measured from the normal. Okay. Same with the angle of incidence. It's from the incident ray to the normal. So again, to repeat, the incident ray is the light ray that comes in and it hits the mirror. The reflected ray is the light ray that bounces off the mirror. The angle of incidence is the angle that the incident ray makes with your imaginary normal line that you're always drawing perpendicular to the mirror. And the angle of reflection is the angle that the reflected ray makes with the normal. So the ray diagram, when we say it's the ray model of light, we're saying that the picture is showing incident rays, reflected rays, normals. It's showing the way that the light ray bounces off of an object, okay? So the light ray shows the path of a light ray when it hits, the ray diagram, shows the path of a light ray when it hits an object. So what is important to note is that your arrowhead shows direction, okay? Without it, you're not going to get the full marks. It's a straight line. We know light travels in a straight line in a ray model, okay? And it's actually going to hit the mirror. This is called that incident ray, and it's the ray that hits the mirror. The reflected ray is the ray that bounces off the mirror. So the reflected ray has an arrowhead that points in the opposite direction away from the mirror. The incident ray, that arrowhead is always pointed towards the mirror because it's actually going to hit the mirror. Once that light ray bounces off the mirror, it's traveling in an opposite direction, which means your arrowhead has to reflect that. The normal is very important. It's a dotted line that is perpendicular, which means it's drawn at 90 degrees to the mirror. It doesn't actually exist. It's what we use to be able to measure the angle of incidence and the angle of reflection. Okay, but it's very important that you draw it in right in the middle. Okay. Okay, and then lastly, you have to remember the angle of incidence and the angle of reflection. So if I do a quick sketch here, that's my mirror, that's my normal. I do an incoming incident ray and an outgoing. Okay, reflected ray. Your angle of incidence is the angle between the incident ray and the normal. So AOI. Okay, so angle of incidence is the angle between the incident ray and the normal line. Your angle of reflection, on the other hand, which I'll call AR, the angle of reflection is the angle between the reflected ray and that normal line. Okay, it is not the entire angle. It's from the normal to the reflected ray or from the normal to the incident ray. Okay. Very important that you draw that normal line perpendicular to your mirror. That way you can measure your angle of incidence and your angle of reflection properly. Okay, that takes us to the end of the first part of our lesson. So just a brief recap. You are responsible for understanding the following terms. An incident ray, the light ray that comes in from the light source and hits the mirror. The reflected ray, which is the ray that bounces off the reflective surface of the mirror away from the mirror. The normal line, which is a 90-degree line that is drawn perpendicular to the mirror. It is drawn as a dotted line and it is useful for measuring the angle of incidence and the angle of reflection. The angle of incidence being the angle between the incident ray and the normal, and the angle of reflection being the angle between the reflected ray and the normal. And remember, this is used for plane mirrors only, meaning flat mirrors. There is a difference between a flat mirror and a curved mirror. We are going to learn about curved mirrors later on in this course, and it gets a little bit more complicated. For right now, we're talking about flat reflective surfaces. So remember, light bounces off of the reflective surface. That light enters your eye, travels through your optic nerve to your brain, and your brain is going to interpret and is going to receive those signals, interpret them, and then it's going to create an image that you recognize. Okay? Email me if you have any questions.